Good morning, everyone. Thanks for joining us here. Hope you're having a great time at NDC. Welcome to my talk, How Success Can Take You to the Brink of Failure. So, who am I? I am Vanessa Love. I, in a past life, was a LAMP developer. And then that led me a bit into Linux hosting support. Currently, I am the lead support engineer at Octopus Deploy, and I've been there for over 3 years. I actually specialise in scale. At Octopus, we do a lot of specialisation within the teams and within the support teams, and I specialise in scale. One of the things about me that led me from being a developer into support is I like talking to people, which is rare among the IT community. I also like helping people, which again is fairly rare. But I really love building relationships with customers and trying to understand their needs and experiences. So, who's heard of Octopus Deploy? Who uses Octopus Deploy? Who's sent me a support ticket that I've answered? Oh, so close. So, Octopus Deploy is a deployment automation company. It was founded in 2011. And it's the market leader in .NET deployment tools. The team that worked on this specific case study was Damien Brady, you might have heard of. He's now at Microsoft. Paul Stivell, who's the CEO of Octopus, and myself. The company that we're talking about during this case study is Accenture. So who's heard of Accenture? Anybody who worked for Accenture Australia? Excellent. So this is from Wiki. Just to, it's obviously the gold standard of what Accenture is. It's a global management consulting and professional services company that provides strategy, consulting, digital, technology, and operations services. We were working specifically with the CIO team in Chicago. That team has 6 delivery centers around the world. The team we were specifically working with was Jim Schubert, Thaddeus Parker, and Ian Paulin. So I might say their names throughout the talk. So I don't have an agenda so much as this is a case study. We're going to go through a timeline of events and talk about what happened during that. There's no real agenda apart from we're trying to learn lessons here and talk about a situation that happened, how it was resolved, what we learned from it. So Accenture wanted to understand about deployment automation. Ian was given the task to evaluate 2 different deployment automation tools. So one of the things I'd like to point out is I've got a little time over in the corner as we go through, just so you can sort of figure out when this is happening. So this was late 2013. Ian was asked to figure out which deployment automation tool would be better, Octopus Deploy or Release Manager. They had, at the time, over 300 apps, which were primarily .NET apps. They handled their deployments back then via tickets to an ops team, and everything was tracked on a spreadsheet. And it was really not sustainable. That's a lot back then. In fact, a word that I've seen used many times is intensive. I've seen it in Ian's blog post. Jim mentions it in a Channel 9 talk. It was intensive. It was a lot. They determined that Octopus was best for them, which apparently surprised everybody. Good to hear. Back then, Octopus was very new. There were 2 people working in Octopus. It beat out Release Manager. So some of the problems that they had to specifically solve were their teams needed to be isolated. Teams couldn't share projects. They shouldn't be able to see each other's projects. They definitely shouldn't be able to change any processes that the other teams were working on. They couldn't share targets, shouldn't be able to turn off machines, interact with machines that another team had, and packages as well. And when it comes to packages, not only not being able to touch other people's packages, they shouldn't really impact each other. And when it comes to packages and naming, and we all know how good developers are at naming things, there were chances with 300 teams that they were going to have very similar names. So they had to have packages that were just not going to impact any team. They also had to integrate with existing tools. At the time, it was TFS and Active Directory. So these are 2 very commonly sneered at, but very common products that are used at an enterprise level. And they had to easily onboard the new teams. Their pilot project was to get 10 teams into Octopus, some with very legacy and some with very new, at the time, very new Azure deployments. And they didn't want to micromanage teams and people. Accenture has a very high turnover of people and developers, especially over a couple of years. They didn't want to have to go into Octopus and micromanage any of that. So the implementation. It was the beginning of 2014 at the time. They had Active Directory and Visual Studio. So an instance of Octopus Deploy was installed. Back then, this was version 2.2, and it used RavenDB. It was a single self-contained Octopus on a VM. So they have three levels of teams for every team: an admin, deployer, processors, and then just deployers. The good thing is with Octopus, you can easily integrate with Active Directory and set them up with Active Directory groups. So they can be managed in Active Directory, which they were already, and all they had to do for Octopus was set it up once and assign it to the right group. Great. And then they started setting up projects. But then we have the package problem. Octopus comes with an internal package repository, but it's shared. It's in the library. Anybody for any project can upload, can use it, can take those packages. So the solution was they installed NuGet Server on their own hardware, and they set up individual feeds for every team. So Team Foundation Server was directly pushing the packages onto NuGet Server, which was then consumed by Octopus. And then they could easily set up their environments. So when it came to setting up the second team, how do you completely isolate these teams in a shared Octopus instance? And the good news is, outside of the library, Octopus is very granular in its permissions. So they could, for projects and environments that they'd pre-set up, assign them only to teams. And then teams wouldn't see each other. They had Jim, Ian, and Thad, and others of the CIO team did have admin accounts across the entire instance where they could do things, but nobody else could set anything up. So then it became really quite easy. They had a system, they had namespacing. There is lots of namespacing when it comes to teams for the teams themselves, the projects, and the environments. They got so good at it that they automated it. They're very, very good at automating. So they had a script for any team that wanted to come in and be introduced to Octopus. They just had to run a script. It got really, really easy. Really, really, really easy. This is an under-exaggeration. This is me trying to fit it on a slide. They ended up with over 200 teams on a single instance of Octopus using RavenDB. Then the inevitable happens. As well as you can implement it, one of the things looking back on this case study is, if Ian had have specifically come to us at the beginning and said, how do we do this, we probably would have told him to do it exactly as he did. We would have said, well, we've got permissions and they're great, and set it up. It wasn't really a consideration about what would go wrong. So we get a distress signal. And if we look, we're actually in April 2015. So we went from the beginning of 2014, everything's kind of okay. They're upgrading, so they went from 2.2 all the way up to 2.5.4. But we get a distress signal. It's a Saturday, and I just happen to be on my computer and checking email, as we all work really terrible hours in IT, and we can't help ourselves when the computer's there. Their Octopus instance was completely unresponsive. Previously, when they'd be having a few issues, they'd been able to at least resuscitate it, but they could not get it back. It ended up being a specific issue with our Raven implementation, and it was Paul and I jumping on a call to Chicago at night on a Saturday, just getting the service back up by teaching them how to do specific things with indexes and all fun manual Raven work. They actually had some consistent and reproducible errors. They would have times during the day where the service would crash or the CPU would spike or everything would get really slow. And then they started just having different load-causing crashing errors. There were many things that contributed to what was going wrong. They made use of polling servers. In Octopus, you can have listening or polling. Polling, as you imagine, polls the Octopus server and says, do I have a job? If it's misconfigured back in their version, again, we're on 2.5.13, it would DDoS the Octopus server. So you could misconfigure a polling tentacle and take down Octopus with it. It wasn't really something we considered. One of the things with this implementation, and what makes it different from majority of people that use Octopus, is the teams didn't really have an understanding of their impact to Octopus as a whole, or they didn't really care about their infrastructure. They weren't looking at, are my machines online, are my machines beautiful? They were building packages, pushing them, and just expecting the other side to work, regardless of if machines were online, if they were correctly configured, which is something we had never considered as a problem that our customers would have. We all assume that you're watching your servers and that you know if they're at least online, and this wasn't considered by the teams that were using this. A second thing that would happen is teams would write bad scripts. Happens in IT, I'm sure we've all done it, but things like they would write a recursive backup of their backups and take down a server. They would write other things that would hammer the Octopus server itself and take it down. So unfortunately, one single team in this case, because we were at such capacity with data, with Raven, with Octopus, could easily take down the server with a really small scripting problem. Then the Octopus server itself. Maybe infamously, our implementation of Raven wasn't perfect. There were things that we implemented with Raven that wouldn't work well at scale. They would get to a point where there'd be so many documents being accessed in specific ways that could stop the service from running. So there were problems with the implementation at this scale. Oh, I'm going backwards, sorry. Another problem we had in this version, which we rapidly fixed, so if you know anything about Octopus, is that we will rapidly fix problems. If there's a bug, there will be, and it's affecting quite a few people, it's deployment related, it's server related. We'll fix it very rapidly and we'll get it out in the next few builds. We had a bug in this version where health checks would only run for a minute. They wouldn't time out or stop being responsive for a minute, they just would stop running after a minute. And with that many tentacles and machines, it meant that they could never successfully health check all of their machines. That meant Octopus didn't have a current state of what those machines were in. And in this version, again, I'm going to say in this version a lot because there were a lot of bugs that we rapidly fixed. But in this version, if you attempted to deploy to a machine that we thought was online but it wasn't, it would stall and it would continually try and contact that machine, which would cause problems. And like I was saying, these teams weren't conscious, they weren't active in the state of the machines they were deploying to. So as well as that, Octopus would have actively stopped them from deploying to offline machines, but we didn't know they were offline because we couldn't health check them. So if you were running a deployment to any one of these machines in an unknown state that was actually offline, it would start queuing deployments, which would bring up CPU usage, server usage, and affect the entire Octopus server. The final problem we had was, in this version, the NuGet libraries that we were using had a handle leak. It wouldn't really affect people with smaller instances. It would take months, sometimes many months, to get to the point where it would stop working. Unfortunately, when you have this many teams and this many packages, that could happen within 24 hours. And the only resolution to clear the handles was to restart the service. So I want to talk a little bit about expectations. would we have expected Octopus to work with this many numbers on that version? And the answer is we had customers with parts of all of those numbers. We had customers with lots of teams, but not lots of machines, not large processes. We had customers with lots of projects, but only one team and maybe only deploying to a couple of machines. All of those big numbers worked in isolation, but any one of those things, when you're doing it as a massive team, would bring it down. Did they expect it to work? They weren't expecting the rapid success that they had internally. They weren't expecting so many people to come through and start using Octopus at such a rate, at such a load. They did say that they knew they were pushing Octopus to the bounds, and we would probably have to agree with that. We get requests sometimes that a customer says, do you handle 30 tentacles? I feel like I have a lot of tentacles. Is 30 big? We're like, we're cool with 30. It's okay. 30 is going to be fine. We have other customers who say, but I only have 1,000 tentacles. And it's the expectation of what they think of size. They think 1,000 is small. Again, we handle thousands. That's fine in the current versions. But the expectation of what customers are expecting of you versus what you're expecting can differ. And Octopus, pretty much during the 2x phase, our customers were small. We had a few big customers like Accenture. We had a few around them. But an average customer would only have 10 projects, maybe 30 machines at max. Majority fit under the community license of 20 things. That was our majority base of using Octopus. And at that level, seamless, perfect, everybody's watching everything. So we had to go into rapid firefighting mode. We had to help them get stable. This became a bit of a crisis for us and for them. We wanted them to be able to use Octopus. They had a lot of teams relying on it. But then we found out that they'd been burned by upgrades. And while I said Octopus itself, we rapidly fix things and rapidly get things out, in early mid-2015, they attempted to upgrade, well, they successfully upgraded from 254 to 2512. Unfortunately, the shutdown of the service, it usually takes between 5 to 8 minutes, which is in their acceptable range, took over 40 minutes to the point they manually had to crash the service to stop it. This time, there are hundreds of teams can't access a server. They're global. There are teams that are awake and trying to do things. Their Raven database size was more than 800 megabytes. A stable Octopus in that version was about 600 was the limit, so they were over that. On startup of the service, we re-index. It took over 2 hours. Every time they had to restart the service, it took over 2 hours for Raven to re-index. And this downtime of this one small upgrade, the upgrade itself was very quick. It's just replacing a few binary files, but the configuration of the upgrade took so long. It was exponentially larger than any other upgrade that I've ever had. They then, once they're finally back into the service, have to upgrade their tentacles. They had 700 machines, or just over 700 machines, and the process just wouldn't run. They found that they had to script a batch upgrade of 10 machines at a time, which is 70 times they had to do it. Back in that version, you could deploy to a tentacle that hadn't been upgraded because they were the same 2.5 to 2.5. However, if there were any new features, it could have caused problems. Back then, our versioning wasn't terribly semantic. So they passed an internal upper management protocol. They're not allowed to upgrade Octopus again until all of these things are resolved. While we resolved some of the issues, polling tentacles no longer killed your Octopus server if they were misconfigured. Some of the load was handled. We couldn't upgrade our NuGet libraries at the time, so that was always going to be a problem for them. But we'd fixed quite a few of the different issues, but they couldn't upgrade. The amount of times I sat in calls and said, yeah, we've fixed that in 2.6. It'd be really cool if you could upgrade. So we started just constantly fighting fires with them. The first port of call was we need to get the load off the server. No matter what, they need to get some of this load off the server. They need to deploy a lot. So we asked them to start migrating teams off that instance into other instances. Any new team coming in, because at this time, even though they were having so many issues, there was still so much success with deployment automation and getting your ownership of your deployments out. Teams still wanted to be included. So we asked them to onboard any new teams onto new instances, stop overloading this currently working big instance. They started enforcing nightly restarts, which fixed quite a few problems. It fixed the handle leak problem, meant it gave it a nightly restart. It reset quite a few of the load problems that it was having. They changed to a listening tentacle policy only. One of the things with the CIO team is while they were controlling Octopus and controlling the setup, they weren't controlling the tentacles or the machines. All the teams were doing that. So they changed it to a listening tentacle policy only because it couldn't bring down the server. And we helped them write at the very top of every process a health check for machines just to see if it was online before it would start deploying. The problem with this is teams could go in and turn it off, delete the machine we were using to do the health checks, cause all sorts of problems. It was not very successful. We did ask them to change their NuGet feeds from URI to file share because the bug only existed if you were using the URL NuGet. If you changed it to a file share, Rob down the back is going, really? Yeah, really. It didn't work on file share. Because they were on the NuGet server, they could easily just link to it as a file share instead of accessing it over the web. So that was successful, and it took away the handle leak problem for them. So we were very active in trying to resolve the problems, bring them online, and learn from this. It could have been a case of not caring. We entered into weekly meetings until we got them to a stable point. From there, we went into fortnightly meetings that lasted a year and a half because we were helping them get stable but also upgrade. We needed them to upgrade to 3.0 because it's going to resolve all of their problems. We learned a lot from this. Every lesson we took from our meetings, we then had a chat and determined what could be done in 3.0 to fix this. Had we fixed this? How could we change things? We actually came up with some interesting models and fixes that every time they say, yeah, this happened again, we're like, yeah, we fixed it, just you wait. So we got to the point of stability. Finally, they didn't have emails flooding their inboxes saying, what's going on with Octopus? I can't deploy. They had 5 servers with single Octopus instances on them. They had 1,564 tentacles, which were all listening, 255 teams across those 5 servers, 509 projects. On their busiest day, they were doing 105 deployments, and they were doing roughly 450 deployments a week. So we went into full planning mode. How are we going to get them upgraded? What would be the best model to handle their scale, to handle their growth? How can we get them into a completely stable Octopus, happy nirvana land? One of the things we started off saying to them, this is something Paul had in a presentation for them, is you just can't expect perfect software. We can't know that we are going to create software that in the model they're using is going to be bug-free, is going to just magically handle load. You can't do this, but what we can do is we can consider what do we want to solve and how we can make that happen. So one of the requests checklist was, can we have different upgrade paths for our teams? Some teams are more forward than other teams, and they want new features that are coming out. In the old model they had, you would have to upgrade all the teams at once. So they want an ability to be able to have teams on different versions and different maintenance windows as well. Because they had 6 different locations, being able to do maintenance on the Argentinian nighttime when Argentina is asleep for their servers would be beneficial because then it won't interfere with India or any other country that is in an awake and alert and a deploying time. they don't want teams to impact other people. So if a team is going nuts, if they do something wrong, if they write a recursive loop, they don't want that team to be able to take down any other teams. And yeah, teams should only be able to break themselves. Teams are going to break themselves. That's going to be, you're going to have, in an organization like they knew, they would have mature teams and they would have teams that would write scripts that would do bad things. So our solution was, we want full isolation for all of these teams. Let's break them apart. Let's do terrible things to tentacles. When I was looking for all of these images, there are lots of pictures of cooked octopuses. I'm a vegetarian and I just couldn't do it, so this was the most appropriate image I could find of breaking apart an octopus. Okay. While we were developing 3.0 and while dealing with this situation, we developed a model called high availability. So what high availability does is you can have one octopus instance, you can have a secondary instance, but they share a database and they share a file share. So anything on disk that you need, to packages, task logs. It gives you the ability to take one down, do maintenance on that server, do whatever you need while the other one's still up and allows you to deploy. So we wanted to go full isolation. We suggested that they have multiple instances. Octopus has always allowed you to do instancing on tentacles and servers. So that was already a feature. And we wanted them to do that. But then we took it a step further. Let's give you everything you want. Let's do this in HA. So they would have what they've called a node set, where it's every team has 2 different Octopus instances that have a shared database and have shared storage. And they had to go big. We suggested that they have multiple of these node sets, which will allow things like one node set could be on a different version from another node set. If they were having really high traffic or one team was overperforming compared to the others, they could move it to another VM that had less traffic or had less load. It gave them more options about what they could do if they were having the problems that we knew they were going to have. But it came with some added bonuses. Suddenly, they could make use of all the library features that they'd never been able to use because they weren't sharing their Octopus instances anymore. So they could use the internal package repository, which meant some of the teams who were using SSH and Linux targets could suddenly upload zip packages and do those kinds of deployments. They could also use the step templates. They had tried to use the step templates in the past, but because it was there and available, if one team wrote a step template that was really specific for their project, another team could find it and use it and then ask why everything was breaking. So they'd never really been able to fully use those features, and now they could. They can be picked up and moved, like I was mentioning. Another problem with our granular permissions is you can get somebody to create a project, but if they are limited to projects in their team, that project gets created outside of their team and it has to be given extra permissions to get back in their team. You needed an admin at some level if you were creating teams or environments, even if you had that ability. Now they could control all of the projects in that instance and all of the environments. So the plan. We know we need to separate all teams into isolated instances, and they're on 2.5. So that means they'll have to upgrade to 2.6. We're going to somehow have to specifically separate their data. They're on a shared instance. It's a single Raven database. When we moved from Raven to SQL, we have a migration path. It needs a 2.6 backup, and we'll move all your data into SQL. They need to create these new instances, and then they're going to take all of their packages that they have in NuGet Server and put them in the internal repository. So we suggested a path for how they do this partway through. They're going to have to upgrade from 2.5.13 to 2.6 just to get the correct backup. They're going to have to somehow isolate the team data. So by importing, maybe they could delete the data and then create a new backup, and then that goes into the new instance. take that backup, and then install an instance of 3x on the new VM and migrate the data into it. And then they can move the packages over. I really like this image because from a support point of view, it's kind of like works on my machine because it's an octopus, right? It's an octopus. There's nothing wrong with this octopus, except it's an image. So they had problems with what we'd suggested. We were thinking at a high level of all the steps that needed to work. But putting it into practice is another problem. It worked in theory. They tested it in one instance, and it took about 3 or 4 hours. For 300 teams, it would take them years to migrate. It's just not possible. Also, part of it couldn't be automated, and it meant that there'd be man-powers and hours and just monotonous repetition 300 times. It also required quite a few temporary VMs to make it happen, especially if you wanted to do it in parallel. So we needed to refactor our thinking on what we could do to fully automate and really help here. So this could have been a time where we just stepped aside and like, well, this is your problem to solve, figure out a way to do it. Instead, we created a very special version of the migrator for them, where it would take a 2.5 backup. We also extended it so they could give it the team namespacing, and it would only migrate the specific team data through. It was all available via command line tools, and suddenly they were using a single backup. So where do we go from here? Hopefully at the moment I'm tweeting a few things, and one of them is a blog post that Ian Paulin wrote, which includes this quote. They are great at automation. So for him, he thinks Octopus is not just about deployment automation, but it's about automation. And we do get that comment a lot. A lot of ops teams use us to do Windows-type things. They don't have to RDP into servers anymore. They can create a project that run upgrades, that do all sorts of things on all of their targets and servers. It makes the ability for them to manage their servers via automation. They do it through Octopus. So what did they do? Like I said, they were going to automate everything. They have an Octopus server that creates Octopus servers. They have a management Octopus server that has scripts in it that they can easily create all the instances they need. It connects to all the servers, it sets up everything. They can create Octopus servers like octopuses were rabbits. Testing. This is another one of those like obscure pictures I liked, because when you're testing, you're not really testing what it is. Kind of looks like an octopus, but it's not really. You're kind of testing it. So we had a few problems when we were testing their process. It was working in all their tests, and then suddenly we got on a call when we were fairly close to one of the first kickoffs of migration. We're in 2016 now. Their latest test of their script and their automation was importing all the data and taking hours, and something went wrong. Luckily, it just turned out to be an error in the PowerShell scripting. They had some legal issues with data. The less data you import, the quicker the import takes, but they had some teams, due to legal reasons, who needed to keep a year worth of deployment data. So that had to be accounted for in some way. This migration might take 3 times as long as the other migrations. And they were scripting it, and they found it couldn't be run from a secondary machine. They had this management Octopus that was trying to call a command line tool on the other servers, but it just turned out, again, to be a bit of a configuration issue. They weren't calling the right flags, and that wasn't actually a problem. When we started getting more and more into this, the problems weren't problems. They were just misconfigurations, misunderstandings. But the good thing was we were there to say, no, you just need to do this, and it will work, and it would. So their entire process was that they had a project in this management Octopus that would prompt for the team names that they were migrating. They would create a new instance on the VM using scripting as part of the process. Using the latest 2.6 backup, they would migrate the team data. Their process would look for a recent backup, and if it didn't exist, it would go and grab one. Completely automated. It would also set up all of their host details for these teams because they all needed a different point of access. They used IIS AAR for their load balancing, set up all the certificates, again, completely scripted. And it was taking anywhere from 30 minutes to 90 minutes, depending on team size. So we're taking the dive, we're getting into it. They told us the date and time of the very first one, and they asked, will somebody be available? And I'm like, well, that's 5 a.m. I'm sure I could be around. Everything will be great. So it went through 6 stages. They had 5 different servers, but they also had special case teams who refused to have a downtime, so they were leaving those to last. Everything was too important. They couldn't have a downtime. They couldn't go down for those few minutes to get it up. They started with the smallest instance. So we're going to do 1 instance at a time, single backup, get all those teams up, starting with the smallest, the least risk. They ran over scenarios. They did a lot of testing. They even had backup plans. The thing about the migration is, while it's doing a lot of stuff, the 2.6 instance does still exist, and if anything went severely wrong, the teams could just go back to using 2.6. It went really well, actually. So that day, waking up a bit early, checking my email from bed, seeing if there's anything I need to do to help. Nothing, no emails, no problems. There were a few little things, but these were all slightly expected. All of the teams would have to change where they're sending their NuGet packages, but they were sent emails about that and told what to update. So that just was communication issues and education issues. There were a few minor problems, potentially with things like step changes. We deprecated a few different step types. There were little things like that, but nothing that was urgent enough that required that they had to go backwards. And a lot of people were a bit upset about the cheese move. So if you know anything about Octopus 2.5, it was vastly different to 3.2. So buttons moving, people were a little upset, and again, education issues about making people try and find where things were. So it was actually very, very successful. We didn't have to get involved after that first migration. We got updates. It took them, I think the first one started in March and the last one was July. So it took them a while to get ready and set up and train and get all the teams ready for the migration. But all of their teams now are on at least version 3.2. This was another quote from Ian's blog. So what used to take 30 minutes, and I'm not talking about the manual processes, I'm talking about in 2.5, it would take about 30 minutes to do a deployment. They were now doing in under a minute or within minutes, and they didn't have to interact as much with Octopus. But the second sentence is the one that I love the most. The time gained and budgeting recouped from all the deployment automation has been estimated to be at least 7 figures. That's what a company of that size can get back in time when they don't have to worry about their deployments, they don't have to micromanage their teams, when teams can own their own deployments. And I'm happy to report there is complete stability. Teams can no longer take teams down. In fact, I haven't even heard of a team taking itself down recently, which is nice. There's no more cases of multiple downtime for teams, specifically not all the teams in the company or all the teams interacting with Octopus. The HA means that they can keep maintaining their Windows servers, take down a node, but keep the other node up and keep deploying 24/7 as they need. And more importantly, they're not having any load issues anymore. The amount of load that was happening on the servers has completely gone away. But potentially that's because of the architecture, which I'll talk about in a bit. The CIO team is very happy to report that they're no longer fighting fires and getting emails about how unstable Octopus is. They're just worrying about onboarding, teaching teams how to package, how to send packages around, what deployment automation is. They say they've gone really back to basic 101 deployment automation. But they still do use their management Octopus to onboard new teams. Process has changed slightly. They don't have to do the migration, but they do put in details and it creates their Octopus over their network. So what does it look like? So they have these VMs that are a dot large that have lots and lots of Octopus servers on them. In fact, they've got 2 for every team, and they call that a node set. Well, actually, they have 8 node sets or 16 dot large VMs. So anybody doing the mental calculations of cost? They have 2 Windows DFS servers that serve all of the files in the system, and they have SQL always on. So they feel that they're in a fully high availability model with backups and disaster recovery, and they're very, very, very happy. And this is all in the cloud as well. And it's working for their teams. Obviously, some teams are getting faster latency to the servers than others, being they have some teams in Argentina and America, etc. So let's talk numbers. This was as of the beginning of the year. They have 320 instances of Octopus. Well, actually, they have 2 times that because that's only counting per team. They have 413 project teams. The reason they have more teams than instances is some teams do share things. They share projects, they share machines. They have 3,000 plus deployment targets. I think this is a slightly inaccurate number because they use Azure as well, and we don't count accounts in our target numbers, so they're deploying to more things than just 3,000. The numbers came in, and they're doing 13,656 deployments a month. They're doing, of those, 1,534 are in production, and they saw between January and March a 6% increase in deployments. For us, the biggest thing about this is a lot of people go through Accenture. A lot of developers use it. They then get exposed to Octopus. How Octopus was running for them in 2.5 wasn't good for us and people seeing what we were doing, and it didn't show what Octopus really could do. It wasn't designed in a way. They could have at that time, because we did have it, could have gone the instance method, but licensing costs and all of these other things, it just wasn't something that anybody really considered. Going forward, it's given them complete confidence. They know that they can onboard anyone and they're not going to have technical problems. They're not going to have load problems. I've seen graphs of their memory and their CPU. Every time they onboard a little team, it goes up a bit and then it just completely levels out. We learnt so much from their information about how we should be doing our processes. We use CPUs. We do all sorts of things now that we hadn't really considered to be at scale. So what is the future for teams like this for enterprise at Octopus? We're going with something called spaces. So every octopus in its space. We have a product called ODCM that's coming out. So again, if my tweets are working, I've got a nice little tweet going out now giving you the link to our RFC. We found that while there aren't that many customers that are enterprise, there are enough customers at enterprise that need to do what we have been calling the Accenture model. They needed to get to a point where they had lots of instances of Octopus because it's the only way they're going to be able to scale and grow. So we were working with these companies saying, you need to do this. They came back to us and said, well, that's well and good for Accenture, who are really good at automating and really happy to do it, but we don't want to really manage all of those things ourselves, write the scripting. So we have a product coming called ODCM, which will let you easily spin up instances, build relationships between the instances, upgrade them individually. They don't even have to be managed on the same network as long as they're accessible. It's going to give people the ability to create these environments that are easier to manage for these situations. Thank you. So I have quite a bit of time if anybody has any questions. Yes?
The instances that they're running to host Octopus Deploy, are they on-premise or are they in the cloud?
In the cloud. Yeah, .large servers in the cloud. Yeah. It just gave them the ability to easily expand or add the way the cloud works, scale it up if they needed to. It's so much easier because it's that case of they don't have to worry about hardware anymore. That's somebody else's problem. Now, anybody else? Yes, sorry. Okay, so the question, if I heard you correctly, was do we have any of the numbers about productivity savings on time? Is that correct? Yeah. We don't have, we're not necessarily given those kind of numbers by our customers, if you know what I mean. We've definitely seen cases where, even there was a presentation the other day that Honeywell gave about how that saved them a lot of time. We get told those stories, but nobody ever is willing to give us their nice little numbers. Yeah. There are things here that even I couldn't really talk about. I had to use all the information that their team had used publicly, if you know what I mean, and talk about Octopus. We hear things a lot, or we definitely hear about problems, but nobody tends to hand over their financial statements, as much as we'd like to see how much it helps them and how much time is saved. Anybody else? Yep.
Okay, so given that they're running all this infrastructure in the cloud and it needs so many servers for hosting Octopus Deploy instances, has there been any work done to see if they could have Octopus Deploy running in containers to thereby reduce the number of servers they need to operate?
Okay, so the question was, could they run in containers to reduce the cost of running all of these? My understanding is Octopus doesn't work currently in containers, but mostly that was because of Docker itself and its Windows networking. I'm waiting for Rob to nod at me or not. Yeah, excellent. Yeah, we're at that point where we really want to get Octopus into containers, and that comes down to we're about to offer a hosted Octopus service where we do our own hosting, and we'd like to actually see it in Linux containers. So we are doing the work. Unfortunately, we were a bit cut off at the knees by the technology itself, and because we were running on Windows, so it was a networking problem we just couldn't finalize. We're hoping with things like .NET 2 being released now that we can work on getting Octopus stable in Linux environments and use Linux containers. So it's something we're actively working for, absolutely, and it could potentially change the cost for them, yeah. Anything else? I've gone fairly under time, but it's lunch, so I don't know if you're all going to complain. All right, thank you very much for coming.